and my team members Sudhakaran, Raghavendra, and Ravishwaran. We are pursuing BTech Information Technology in Tech Marketing. Our project is a novel deep learning gastro-vision algorithm for diagnosing gastric cancer. Gastric cancer. Gastric cancer is the most common cancer and the fourth leading cause of death in according to the survey of 2020. Mostly gastric cancer can be developed in the upper stomach of the body, which requires a deep cancer tissue in the upper vertex. The main motto of this project is to assist the pathologist to get the information about the stomach cancer and identify the cancer where the cancer cell is presented in the stomach. By leveraging, we proposed this method by leveraging the deep learning algorithms. The first, we get the data set and we pre-process the data set into a novel deep learning model, and we compare and we predict the cancer tissue which is in normal, stage 1 or in stage 2. The problem statement. The problem statement of the project is to, in the traditional method, the diagnosis of pathological image, which means a stomach cancer image, can be diagnosed in a decision-making method. Where in our reference paper, there is a method used intelligent decision-making algorithm, which is only based on a text based and the image, where the algorithm will compare both the text and image and makes the decision. Maybe the decision will be wrong due to some lack of knowledge, lack of input image, or in the lack of information in the text based. So it is the accuracy and the error rate is, accuracy is very less and the error rate is very long in the reference paper. But in our proposed system, we mainly focus only on the image, where it will make the decision, not in decision, it will show the segmentation of the input image. It don't make any decision, it just make the algorithm will make the input image and identify the cancer cell and segment the cancer cell separately in the mask image. It will show the output in ones and zeros. The ones will be in white shade and the zeros will be in black shade, where the zeros considered as the normal tissue and ones considered as the cancer tissue. Advantages. There are more advantages in our proposed work. It helps a pathologist, which means doctors, to make the precise decision on making the identify the cancer patients and giving prior treatment to the cancer patients, and identify the normal patients like ulcer, etc., and to take the and give the treatment according to it. It will reduce the lack of information, lack of decision making, and it will also help the patients to improve their improve their health. Existing system. That is what I said earlier. They proposed a novel intelligent decision making method for gastric cancer screening. IDGCS is the main algorithm which is used in the existing system, where IDGCS is a hybrid attention mechanism where it focuses on only textual semantics from multimodal gastroscopic reports, and it shows the textual gastroscopy reports and images, resulting in improved interpretability of gastroscopy findings, which means it consider both the textual gastroscopy and the images and make the decision making according to it. The disadvantage is it is a time consuming process and labor intensive. Multiple explorations are needed for diagnosing the stomach cancer. The accuracy of the prediction is very less and the error rate is very high, and it is not applicable to real time. The IDGCS method is slightly worse complexity and fitting. As I earlier said, the complexity in the reference model is very less and the data set used are not recommended for diagnosing the stomach cancer. This is our proposed architecture, where the first step is to import the input image for data augmentation, which converts the raw data into the understandable format of the algorithm. While after the data augmentation process, we enter into the data pre-processing process. In the process, it will reduce the noise and the other unnecessary effect in the input image and make the input image very clear for the algorithm model. Next, image annotation. Image annotation, it consists of three types: segmentation, object detection, image classification. It classifies the input, raw input image, pre-processed input image, and it detects the object in the image, and the raw data will be changed into understandable format using the pre-processing method. Once the pre-processing method is completed, it then gone to the image annotation method. Image annotation consists of mainly three methods: image classification, object detection, and segmentation. It will classify the input image, understandable pre-processed image, and it detects the object in the input image, and it starts segmenting to train into the algorithm model. It also classifies by using label method. Now we are entering into the algorithm. Mainly we are using three algorithms in a hybrid model: multitask net, global net, and fusion net. Where multitask net will create a separate neural network which is used to maintain the multitask, which is used to do a multiple tasks simultaneously for the model. Where the global net is used to get the extracted features from the multitask net, and the fusion net will segment the extracted feature from the global net and shows the accurate precision for the cancer tissue. While the algorithm got finished, the extracted feature from the algorithm model will be getting matched into the training data set. Once the pattern matching is completed, it will get into the disease prediction model, which is a decision making model. According to the algorithm extracted feature, the disease prediction will be conducted, and if the disease is present, it will show a segmented output image which is in the binary mask, and will classify the input image, cancer image, and the normal tissue. The cancer tissue will be in the white and the normal tissue in the black, and if it is absent, it will show a fully black, which is normal. Now let's see how the code compiles and runs, and let's see the output. This is the input image. We done various methods like data augmentation, pre-processing, and we annotate the image and enters it in the hybrid algorithm called gastro-vision. And once the algorithm got finished, the feature got extracted, and it got matching into the trained data set. Once the matching pattern is completed, it next starts to make the decision by disease prediction. If it is present, it shows this line. Here, this is the image. This is the binary mask image where the black shows the normal tissue. This white are the cancer spread tissues. So this is in stage 1. We are separating all this by the size of the cancer cell. According to the size of the cancer cell, this type of stage will be classified. Comparing to the cancer tissue size, it is considered to be a stage 1. Now the input image is in the stage 1 of stomach cancer. That's it. Thank you.